So basically what we have to do, we have to find out what is the work input to the compressor when you are considering the clearance volume. You know? So if you can see, we know that the area under PV diagram will be give us what work done. So if you see, you can see here there are two without clearance diagram will be there. See, from here to here 5 to 1, then 1 to 2, 2 to 3, and 3 to 6. There is your one without clearance diagram. Then another one is your where your 1 to 2 is your what? The polytropic compression here. Then if you see here, which one? If you see that 5 to 1, if you see here, the 5 to, wait a second. If you see here, the 5 to 4, 5 to 4, 4 to 3, and 3 to 6. So if you consider 5, if you consider 5 to 1, 1 to 2, 2 to 6, 6 to 5, minus of 5 to 4, 4 to 3, 3 to 6, 6 to 1. Then we can find out what? So if you minus this one, these two, then we can find out what? We can find out the actual work. So see, area under 1 to 2, 2 to 3, 3 to 4, 4 to 1. That area we have to calculate. So that what we can say? What we can take? We can take 5 to 1 area, 5 to 1, 1 to 2, 2 to 6, minus of 5 to 4, 4 to 3, 3 to 6. So if we consider these two areas, this will be without clearance. So for without clearance, we know the what is the formula that is n by n minus 1 P1 V1 P2 by P1 into n minus 1 by n minus 1. Clear? So what is the pressure here? 5 to 1. That is your P1. What is the volume? V1. So P1 V1 n by n minus 1 P1 V1 into P2 by P1 to the power n minus 1 by n minus of 1. So if you consider your 5 to 4 process, which process 5 to 4, what is the volume? What is the pressure? Pressure is your P4. What is the volume? V4. So P for V4. See, P for V4, n by n minus 1, P for V4 in case of P1. What is the pressure here? P3. What is the pressure here? 3 to 4 means P3. Pressure, initial pressure is your what? P4. So P3 by P4. P3 by P4 to the power n minus 1 by n minus 1. So we know that 4 to 1 is your what? Constant pressure suction. So we can say that P4 is equal to P1. We can say that P4 is equal to P1 and P3 is equal to P2. So in place of your P4, if you can put what? P1. And in place of your V4, what we can put? That is V4 will be left here. So here in case of your P3, we can put P2, P4 by. In case of your P4, we can put. In place of your P4, we can put P1. In case of your P3, in place of your P3, we can put P2. And in place of your P4, we can also put P1. Why? Because 4 to 1 is your isobaric constant pressure suction. So P4 is equal to P1 and P2 to 3, that is your constant pressure delivery. So P2 is equal to P3. So here see, here P1 and P1 is there, n minus 1, n by n minus 1. And P2 by P1 to the power n minus 1 by n minus 1. Here also P2 by P1 to the power n minus 1 by minus 1. So it will be taking common. So what is left? N minus 1 we are taking common. P1 we are taking common. Another one. P2 by P1 n minus 1 by n minus 1 I am taking common. So what is left here? Left is your V1 minus of V4. Left is your V1 minus V4. So what is the formula? N by n minus 1 P1. Suction is your V1 minus V4. That is known as your what? That is known as your effective sweat. That is known as your what? That is your effective sweat. With this sort of volume, the air will be enter into effective sweat. Yeah. So that is your formula for what? That is the formula for your work input to the compressor when you are considering with clearance. With clearance. These are with clearance. Okay. So that is the work done. The question will come. We will derive the work done for work input to the compressor with clearance. With clearance. Next we will discuss volumetric efficiency. So what is volumetric efficiency? That you basically know what is volumetric efficiency. We know that volumetric efficiency is defined as the actual volume of air sucked into the compressor at atmospheric pressure or temperature to the piston displacement volume. So now, how much air will be enter into the cylinder according to the piston displacement volume. So what is your piston displacement here? You can see the piston displacement volume is your what? Swept volume. But what amount of air will be enter into the cylinder? That is your effective swept, that is your V1 minus V4. So actual volume by swept volume. That will be give us what? That is your volumetric efficiency. So see here, volumetric efficiency is your effective swept by piston displacement. So what is your effective swept? V1 minus V4. What is your piston displacement volume? Total volume is your, see here. Total volume is your V1 and this is your Vc. So V1 minus Vc is your what? That would be a swept volume. So here I can put V1 minus Vc. V1 minus Vc. So what is V1? V1 is your Vc plus Vs. What is V1? V1 is your Vc plus Vs. Then Vc, Vc will be cancelled out. So Vs plus Vc minus V4 divided by Vs. So if I put here Vs by Vs is your what? 1 plus Vc by Vs minus of V4 by Vs. So to give a term in clearance ratio, to convert into clearance ratio, I am multiplying here Vc and dividing by Vc. So 1 plus what is your Vc by Vs? Vc by Vs is your clearance ratio minus V4 by Vc into Vc by Vs. What is your Vc by Vs? Clearance ratio into V4 by Vc. So what is Vc? Vc is equal to V3, that you know. So in place of your Vc, I can put V3. So what is your volumetric efficiency? 1 plus clearance ratio minus the clearance ratio into V4 by V3. That is known as your what? That is your volumetric efficiency. So what is your 3 to 4? 3 to 4 is your polytropic expansion. So what is the relationship between volume and pressure? V4 by V3 is equal to P3 by P4 to the power 1 by n. Why? Because polytropic process P4 V4 to the power n is equal to P3 V3 to the power n. From that we can calculate. So in place of your V4 by V3, what we can put? P3 by P4 to the power 1 by n. So we know that P3 is equal to P2. Why? Because 2 to 3 is your delivery, constant pressure delivery, and 4 to 1 is your constant pressure suction. So in place of your P3, I can put P2. In place of your P4, we can put P1. So the equation become 1 plus clearance ratio minus of clearance ratio. In place of your V4 by V3, what we can put? P2 by P1 to the power 1 by n. What is your P2 by P1? That is your pressure ratio. So that is basically your volumetric efficiency in case of your what, when you are considering the clearance volume. So next we will discuss in the two-stage compressor.